All right, we are on the last slide of chapter 1 finally. There's 2 more problems and then we're done. So the problem on the last slide at the top, we have a metal sphere or a metal ball. The circumference of the ball all the way around is 12 inches. The ball weighs 10 pounds. We are searching for the density of the metal that makes up the ball. Okay? Now, the way we do this, essentially, we know that density is typically given in 1 of 2 units, which are actually equivalent to each other. If my volume is given in milliliters, it'll be grams per milliliter. If my volume is in centimeters cubed, it's grams per centimeter cubed. But if you remember, milliliters and centimeters cubed are the same. So either way, it doesn't matter, just pick one. Okay? Sometimes that throws people off when they're looking at a problem. So for my density, I need to find the mass and put it on top. I need to find the volume and put it on the bottom. If I divide it, I got my answer. So how am I going to get it? Well, first of all, the mass that goes on top, I need grams. It's pretty easy. We've done it before, changing pounds to grams. You just look up a conversion. 1 pound is 454 grams. Multiply 10 times 454. That's going to be 4540. So that's my mass. That's what goes on top. Okay? Now, my volume, though, is going to be a little bit harder. I have a sphere, and I need to know the volume of a sphere. Again, this is something I wouldn't expect you to know it off the top of your head, but you should be able to figure this out if you can go get information that you need. Sometimes these problems are going to require you to remember some algebra or geometry that you haven't used in a while, okay? But you got to be able to find it when you need it. So the volume of a sphere is 4/3 pi r cubed. So basically, in order to get the volume, I need to find the radius. How do I find the radius? Well, they gave me the circumference is 12 inches. And if you remember the circumference, I don't know what symbols used, I'll just call it C. The circumference equals 2 pi r. So basically, if the circumference is 12 inches equals 2 pi r, then I should be able to divide the 2 pi over and get the radius. So 12 divided by 2 and divided by pi gives me 1.9098. The radius equals 1.909, we'll call it 99 inches. Now, when you're working one of these problems, it's tempting to go ahead and round it off to the right sig figs in the middle of the problem. I would recommend you not do that. If the whole problem is about multiplying and dividing, then technically by order of operations, all multiplying and dividing steps should be done simultaneously, which means you should do all the calculations and then round at the end. The only time you'd want to round in the middle of a problem is if you're switching between multiplying and dividing and adding and subtracting. Anytime you switch back and forth between those, that's the point where you want to do a rounding, okay? Otherwise, most of these problems that are multiplying and dividing, just round the final answer and that's it. So, I got 1.9099 inches. I'm going to go ahead and switch into centimeters right now before I plug it in up here so that my volume will come out to be in centimeters cubed. So, how do I change inches to centimeters? Again, you'd have to look it up. I know that in 1 inch there's 2.54 centimeters. So that's what you would look up. 1 inch, 2.54 centimeters. So let's multiply that. I got 4.8511. Okay, so that's my radius that I'm going to plug in right there. If I plug that in, I should be able to get my volume. So I'm going to do that number cubed. I'm going to multiply it by pi. And then times 4/3. So I got, assuming I did this right, 478.2. And if the radius was in centimeters, I cubed it, that's centimeters cubed. So that's the number that goes over here, that's my volume that I'm putting in my density. So if I have grams per centimeter cubed, all I have to do is divide it. That will be my answer. So I got about 9.49, but technically the sphere was given in as 12 inches, which is only 2 sig figs. So I'm going to round it to 9.5. So my density is going to be 9.5 grams per centimeter cubed. That's my final answer right there. All right. So now we have one more problem. So the last problem is kind of silly, but it's a temperature conversion. So Goldilocks is in a room, and the temperature in the room is 175 Kelvin. So Goldilocks is a little girl. Would she be hot? Would she be cold? Or would she be comfortable? Well, for most people, if you look at this problem and think about Kelvin, people aren't really familiar with Kelvin, so they can't really make a good judgment. So they would have to switch it from Kelvin, 175 Kelvin. We have a pretty simple equation that we can switch that into degrees Celsius. You do need to know that equation. To go from Kelvin to Celsius, you're going to add 273.15 if you're going to keep decimals. But here, if it's to the whole number here, I'm just going to stay with that. So if I add 273 to 175, then that's going to be, should be able to do that in my head, 175 plus 273, it's going to be 448. Oh wait, I went backwards. Should be subtracting. When I go Kelvin to Celsius, I'm subtracting 273. I should be paying better attention. So 175 minus 273, that's actually going to be negative 98 degrees Celsius. So a negative temperature, remember, freezing point of water is 0 degrees Celsius. So negative 98 is really low. And then if you still weren't sure, you could actually convert that into Fahrenheit. The equation for Fahrenheit, degrees Fahrenheit, I think it's 1.8 times the degrees Celsius plus 32. So you can multiply that out and figure out what it is in Celsius. What it is in Fahrenheit. Okay, but at this point, if temperature is negative 98 degrees Celsius, I'm pretty sure that Goldilocks would be cold. Okay, the point of this problem is just you need to be able to convert between Kelvin and Celsius for sure. And then it's not a bad thing to know Fahrenheit, but again, I'm not going to make you do that on the test, so don't overly stress about it. That's the end of chapter 1. We'll start chapter 2 soon.